Hi, this is Rica Maybe Paloma. I am teaching secondary mathematics, and today we are going to talk about the two important concepts in linear algebra: the coordinates and the isomorphisms. These concepts will help us understand how we represent vectors and how different vector spaces can be considered essentially the same, even though their elements and operations may look different. So let's start with the coordinates in vector space. In simple terms, coordinates tell us where vector lies in space based on a chosen set of vectors called bases. So consider the vector space R squared, which consists of all two-dimensional real vectors like x and y, which x and y are real numbers. To understand coordinates, we need bases. So a basis for a vector space is a set of vectors that are linearly independent and span the space. So in R squared, the standard basis is equal to B is equal to the set of 1, 0 and 0, 1. So these two vectors are the building blocks for all other vectors in R squared. When we can think of this as the unit vectors along the x-axis and y-axis. So any vector in R squared says x, y, v is equal to x to y, can be written as a linear combination of these two basis vectors. In other words, v is equal to the x, 1, 0 plus y, 0, 1. So the coordinates of v relative to the standard basis are just x and y. These are the coordinates of v in the standard basis. So let's look at an example. If v is equal to 3, 4, then the coordinates of v in the standard basis are just simply 3 and 4. So this means v is 3 times the first basis vector and 4 times the second basis vector. So now, let's think about what would happen if we chose a different basis instead of the standard basis. So let's take the basis. B prime is the set containing the vectors 1, 1 and 1, negative 1. We can still represent any vector v equal to 3/4 in this new basis, but the coordinates will be different. So to find the coordinates of v relative to the new basis, we need to express v as a linear combination of 1, 1 and 1, negative 1. So we set up the equation v equals a times the vector 1, 1 plus b times the vector 1, negative 1. And this leads to the system of equation. The vector 3, 4 is equal to a times the vector 1, 1 plus b times the vector 1, negative 1. This gives the system of equations a plus b is equal to 3 for the first component and a minus b is equal to 4 for the second component. Solving this equation, we find a is equal to 7 over 2 and b is equal to 1 over 2 or 1/2. Therefore, the coordinates of v relative to the new basis are the set of 7 over 2 and 1/2 or 1 over 2. So notice that the coordinates are different because the basis vectors themselves are different, but the vector v is the same. Changing the basis gives us the different way to represent the same vector. So now we understand coordinates. Let's talk about isomorphisms. An isomorphism between two vector spaces is a map that shows the two spaces are essentially the same in terms of their structure, even if their elements look different. So an isomorphism is a bijective. So it's a bijective linear map between two vector spaces. A map is bijective if it is both injective or 1-to-1 and surjective is onto. So this means that every vector in the first space maps to exactly one vector in the second space, and every vector in second space has a pre-image in the first space. Let's look an example on isomorphism. So consider the vector spaces both are squared. We will define a map. Pi of x over y equals the quantity x plus y divided by the quantity x minus y. This is a linear map because it satisfies the properties of additivity and homogeneity. So let's check if pi is bijective. First, we need to check if it's injective. To do this, we solve pi times the quantity of x and y equals 0, 0. So this implies, or which gives the system, x plus y equals 0 and x minus y is equal to 0. So solving these equations, we get x is equal to 0 and y is equal to 0. So v is equal to 0, 0. Thus pi is injective. So next, let's check if pi is surjective. For any vector u, v, it's the element of r squared. So we need to find v is equal to x y, element of r squared, such that pi x over y equals to the quantity of x plus y, and the quantity of x minus y is equal to the quantity of uv. So this system of equations x plus y is equals to u and x minus y is equal to u. Solving for the x and y, we get x is equal to u plus v over 2 and x is equal to u minus v over 2. Therefore, pi is surjective. So since pi is both injective and surjective, so therefore it is a bijective. So since we can always find such a pair of x and y for any uv, pi is surjective. Since pi is both injective and surjective, it is bijective map, and therefore pi is an isomorphism. So to summarize, coordinates give us the components of vector relative to specific bases. The coordinates change if we change the basis, but the vector itself remains the same. And an isomorphism is a map between vector spaces that preserves the vector space structure. If two spaces are isomorphic, they are structurally the same, even if their elements look different or they are represented in different bases. By understanding these two concepts, coordinates, which depend on the choice of bases, and isomorphism, which preserve the structure of the vector space, we can compare different vector spaces and their elements in a meaningful way.